Okay. So I have shared my whiteboard. Yeah, and I guess you are able to see it. Okay. Now today we are going to talk about the speed time graphs, okay? But in order to understand speed time graphs, we need to understand the difference in three things, okay? The first thing is distance. The second thing is speed. And the third thing is the acceleration. Okay, now this is a very, very easy topic. So we would be able to do that, inshallah. Okay, distance, speed, and acceleration. Now there is a link in this. Okay. Now basically, speed is distance traveled divided by the time taken. And acceleration is basically speed divided by time. Okay. So you need to understand one thing, that there is a link in distance, speed, and acceleration. Okay. So we are done with the basic understanding, right? Are you clear with
Yep.
this? The link in distance, speed, and acceleration?
Wait, how is speed divided by time acceleration?
Okay. So basically this is the formula, right? In order to
Yep.
find the acceleration, you do speed divided by time, and that
Yep.
gives you the acceleration.
Okay.
Okay.
Yep.
All right. If you are interested in how, so in order to explain that, you can think about it that if your speed is increasing, let's say, let's say, um, you're going on a car and initially the speed was zero. Okay, obviously when you start the car, it's at rest, so the speed is zero, and then after, let's say, 10 seconds, the speed gets 20 kilometers per second. Okay, let's say. Now the acceleration would be 20 divided by 10, that is 2. What exactly is the acceleration? Acceleration is basically the change in speed with time. Okay. So the more
Yep.
the acceleration of the car would be, the more would be its speed. Okay. So you can think about it as, as if you're sitting in a car, and if the speed is increasing, that means it's accelerating more. Okay. In order to keep things simple, just know that acceleration is speed over time. Okay, it is a formula. That is it. Just like area is length into breadth, so just like speed is distance over time, acceleration is speed over time. Okay,
Yep.
just get comfortable with the formula. That is it. It's okay if you're not able to understand it this way. When we'll get into the graphs, you would be able to understand it that way. Okay, but this is the link in speed, distance, and acceleration. You use distance in order to find speed, and you use speed in order to find acceleration, and you are dividing both the terms with time. Okay, that is good. All right. Now we need to understand the graphs. Okay, so I am going to start the discussion with the distance time graph. So this is the distance time graph. Okay. Now I am
Yep.
going to draw a random shape. Let's say this is the shape of the graph. Now,
Yep.
Abdullah, what exactly is this graph telling you? Okay, now obviously this graph has distance on y-axis. So it is giving you information about the distance, that at time equals 0, the distance traveled was 0. Let's say this point is 1, this point is also 1. So what is the other piece of information? That at time equals 1 second, the distance traveled is 1 meter or 1 kilometer, whatever the units are, right? So you have
Yep.
two things so far. You are able to find out the distance traveled in, let's say, 1 second, 2 seconds, 3 seconds. So you have two things. You can look at the time, you can look at the distance, but you have another thing as well that is not there apparently, but this is what we are going to talk about. The slope of this red line is what? M, or slope of any line, is basically rise over run, right? And what is rise? Rise is the y-axis quantity, that is the distance. So it is basically distance divided by what is run? Run is the x-axis quantity, so that is time. And what is distance over time? Distance over time is speed. So the distance time graph is not only giving you information about the distance traveled and the time taken, but also the speed of, whatever the thing you are talking about in the question, right?
Yep.
Did you understand the concept? Please be honest. Okay. Do you know how to find slope of any line?
Yeah, I did.
Okay. So it is rise over run. Rise is the y-axis
It's
quantity, that
the
is,
gradient.
yeah, it is the gradient. Yes. And y is the distance quantity. X is time. Distance over time is speed. Okay. This is what we discussed in the very beginning. Okay. So we know that the distance time graph is giving us the speed. Okay. In general, make this a rule. Whatever graph you're making, divide this quantity by this quantity, and whatever thing you get, think about that thing as the slope of the graph. Now, the slope or the gradient of this graph is basically the speed. Okay. You'll see, we'll talk about the types of graphs. Now, obviously, this is one type. It could be that we had this type of a graph. It could be that we had something of this type. Now, obviously, we can have any shape. So you will see that by studying different shapes of this line, like it could be a curve, it could be a line that is coming downwards, it could be a line that is going upwards. We will talk about the speed. Okay. This is the
For
speed type
curve,
of
for
a,
the curve, you can just draw a tangent.
yeah, exactly. Okay. But you have two types of curves. Okay. So it could be that you
Yeah.
have this as well. We'll get to that. Do not worry. Okay. But now let's
Yep.
understand that the slope or the line of distance time graph, the graph is basically giving you speed. Are you clear with this?
Yep. So
Hmm.
slope of distance time graph gives you speed. Yep.
Yeah. Okay. That is amazing. Okay. Now let's talk about the next thing, that is the speed time graph. Okay. A speed time graph will help you with two things. This is the speed and this is time. Okay. Again, I'm going to talk about the simplest example and then we'll talk about different cases later on. Let's say this is the line. Again, the same concept. The slope or the gradient of the green line is basically rise over run. Now we are big enough to write down the rise quantity, that is speed, divided by the run quantity, that is time. And before talking about the graphs, I told you acceleration is speed over time. Okay. So this
Yep.
is going to give you the acceleration. Okay. Because this
Yep.
is the formula. We don't care if we have understood the concept or not. The formula for acceleration is speed over time. So if the y-axis has speed and if the x-axis has time, y over x would basically be the slope. And this means the slope in case of speed time graph is acceleration. That is it. Okay.
Yep.
Okay, that is good. But speed time graph does not only give you information about the acceleration, but also another thing. Now, we have two things in a graph, okay? One is the slope, and the second thing is the area under the graph, okay? The slope is basically y over x, okay? And
Yep.
the area under the graph is basically y multiplied by x. Okay, now we have these two rules in general. Okay, it's not only in maths, it's in physics as well. This is a general rule. Whatever graph you have, the slope would basically be the quantity that you are getting from y divided by x, and the area under the graph would give you the information about the quantity that you get when you multiply speed with time. What do you get when you multiply speed and time? Any idea?
Speed times time equals distance.
Excellent. Very well done. Speed multiplied by time gives you information about the distance. This means that the area under the graph, under the curve of speed time graph would give you information about distance, right? So this is what we know so far. About the speed time graph, the curve is going to give you information about the acceleration. The gradient or the slope is giving you information about the acceleration. And the area under the curve is basically giving you information about the distance. So this is basically the distance traveled, and
Yeah.
the slope is giving information about acceleration, right?
Yeah.
Okay. That is good. All right. That is good. And then acceleration over time, we did not talk about that quantity. So far, we will not talk about acceleration time graph. Apparently, acceleration time just gives you acceleration and time. Okay. We don't know what is acceleration over time. So we don't talk about that. Okay. Obviously, we
Yeah.
will talk about acceleration time graph as well, but not at this point. We'll talk about that in the past paper questions, which we will do after this. Okay. The next thing is to understand the differences. Now we need to understand the shapes of the graphs. Okay, just give me 1 second. Let me take out the notes for that. Okay, all right. Now I am going to make 9 graphs. Just give me 1 second. I need to just make the boxes first. This concept is very, very important. So I'll define the graphs here. And then we have 3 types. Okay. So yeah, the boxes are not proper. Let me just remove these lines because they are very irritating. Okay, yeah, let's keep it this way. Okay, let's talk about the 3 types of distance type graphs. Okay, so let's say we have the distance time graphs in the first row, and then we have speed time graphs in the second row, and then we have acceleration time graph. Okay, so let me make the very first type of the distance time graph. Okay, let's say you have this line. Okay, now obviously this is distance and this is time, and you have a straight line. Okay, now you know that this line right here is telling you, is giving you information about speed. Speed is basically the gradient of the distance time graph. And you know well that the gradient at this point, at this point, at this point, at this point, at all these points is same because it is a straight line, right?
Yeah.
So, and what else do you do? Is the gradient positive or negative?
The gradient's positive.
Very good. Okay, so you can make a rough sketch for the speed time graph. You know that the gradient is positive and it is constant. It is same because gradient on a straight line does not change. This means that the speed time graph would be a straight horizontal line. Okay, why is it like
Yeah.
that? It is a straight horizontal line because first thing, it is going to be, just give me 1 second, this is time, this is speed, and it is positive because the slope is positive. Okay, and the second thing is that since the this line is straight, the slope is same, so for time equals 0 till t, the speed is not changing. That is why it is a straight horizontal line. Did you understand this?
Wait, so the
Hmm.
speed is staying the same as time goes on. That's why it's just a straight line.
Yes, but I am getting this graph using the graph above. Okay, I did not make this graph using the assumption that speed is positive and it's not changing. I use the pink graph. Now I know that the pink
Oh,
graph is
because the
basically,
distance is changing in the top one, but the speed is still constant. But you've changed distance and speed, so
yes,
it
okay,
it
listen,
goes
listen.
like
Just follow this line. This line is giving information about the speed. Number one, it is positive. Number two, the gradient is constant. What is the gradient of the pink graph? It is the speed. Since gradient is constant, speed would be same for all the time, right? That is why we are getting a
yeah,
horizontal line. Okay, and now if your speed is not changing, if your speed is
yeah.
constant, what does that mean? Your speed is constant, your speed is not changing, then what
Then your
would be?
acceleration's constant, or
No,
your acceleration is zero because you're not
excellent.
accelerating.
Very good, very well done. So I am going to use a different color and I will make a line on the x-axis. Okay, so this means the acceleration is zero. Very good. All right, that's really good. Let's talk about another case. So let's say this time around, I have a line that is coming. Yeah, okay. No, not for this. We can think about it for this for speed. Okay. Let's talk about this now. Okay, this is the graph. Okay, think about it as a smooth curve going upwards. Yes. What exactly is
Yeah.
happening now?
Well,
Now,
you have distance and you have time,
hmm.
and it's accelerating
No, this distance
until.
time graph is not giving you any information about acceleration. Okay,
Oh
distance
wait, no, no,
time.
no. So
Yeah,
it's speeding up
very good,
as it goes along,
very
but
good.
then eventually it gets quicker though. So like the speed is quicker towards the end rather than at the start because the distance is going up with less time.
Very good. That means if I make tangent lines on different points in order to study the gradient, because the only piece of information about speed that can be seen from the distance time graph is the gradient. The lines are getting steeper as I am going up, right? Since the lines are getting
Yeah.
steeper, that means the speed is increasing, okay? And this increment in speed is constant. So this is what I am going to have for the speed time graph, right? Again, the speed is not constant because the steepness of the tangent lines is increasing as I'm going upwards, okay? That means the speed would be changing, okay? And that is what I have, right? the speed is increasing. Okay.
Yeah.
Did you understand this?
Yes.
Okay. And whatever I'm writing down right here is basically for general, right? Like the concepts are not going to change in questions. This is what we have in general. Obviously, for questions, things might differ, but this is the basic idea. If you have a slope like this one, then the speed time graph would have a straight line. Okay, so this is what we know in general, and we are going to stick to the concepts. Okay, and now again, what would be happening in case of acceleration time graph? Yes.
So it's speed and time. So it shows speed divided by. So the gradient would show your distance, and it shows your distance increasing.
Speed time graph, the gradient is giving you acceleration. Okay, acceleration.
Ah,
And
yeah.
okay, and look, different points, the slope is positive and the gradient is constant. The gradient is same because this is a straight line. So we are going to follow the same concept as we followed for that. Okay, if distance time graph was a straight line going upwards, like in case A, then the speed time graph was basically a horizontal line. Similarly, if speed time graph is a straight line, like the orange graph that we have, then certainly the acceleration time graph is going to be a straight line of this type. Okay, we are going to follow the same concept. Look at this, Abdullah. Speed, time. The gradient, the slope is giving you information about acceleration. The gradient is
Yeah.
positive because the line is going upwards. The gradient is constant because on all these lilac or purple points, the slope is same since this is a straight line. Okay. So that is why the acceleration is going to be same and it would be positive, right?
This constant acceleration because the distance and the time.
Speed and time. Speed and time.
What about, so in the first graph, but it's speeding up, right? The speed is increasing.
This graph?
Yeah.
The
No, no,
speed
yeah, that one, the second one.
this one?
Yeah, the speed
Okay.
is increasing. So
Yeah.
that means on the speed time graph, then it's constant acceleration.
Yes. Yes. Okay. And this is
Okay.
what constant acceleration looks like on acceleration time graph. Okay.
Oh, okay.
All right. Now I would want you to make all the cases for this. So this time around, this is the distance time graph. Okay. This is the distance time graph. Forget about everything. Okay. Just know that your first step would to make the speed time graph. In order to make the speed time graph, you are just supposed to study the slope of the distance time graph. And how are you going to study the slope of distance time graph? By making different tangent lines. Because I'm just going to make different tangent lines for you. And then I want you to tell me whatever you think about the graph. Not this.
Oh, okay, so it's a curve. So the speed time graph one
The second graph that we are supposed to make now.
would be top left to bottom right.
Top left to bottom right. Very good. Yes.
Deceleration.
Are you talking about this one?
Yes.
Very good. Why? Because
the speed is decreasing because as time goes on, distance like covered is slowing down.
Excellent. Very good. The lines are getting flatter. So that is why it is coming that way. Very well done. Okay. And what do you think about the acceleration time graph now?
It would be, let's see, this would be, would it be a straight line, just straight, but in a negative number, so underneath 0?
Very well done. Yes, excellent. Excellent. Very good. It would be somewhere here, right? Because again, the
Yep.
acceleration or deceleration, whatever you want to call it, it is negative and it is constant. Okay.
Constant.
So the value would be same, but it would be negative. So that is why, but this is what we're going to have. Very good. Okay. All right. So let me see if I have anything else to tell you before talking about those questions. I think that is pretty much it. Obviously, when we do questions, so then I'll tell you if we have something else to discuss. So I'll stop sharing this and now I'm going to share the questions with you. Okay. Okay, so I am going to share the PDF that I made for the questions. Right, so I have shared that. Okay. So it says the diagram shows the speed time graph for a car traveling between two sets of traffic lights. Okay, let's just try understanding this. Okay, so basically the speed initially was 0 at time equals 0. Okay, this is what we have. Then the speed increased gradually to 16 meter per second at 10 seconds, and then the speed was constant. The speed was 16 meters per second for another 10 seconds. That is from 10 to 20, the speed was constant. And then the rider must have seen the traffic lights. So he or she started decelerating. So the speed decreased to 0 again after 5 seconds, right? So did you understand the idea about it?
Yes, I think so. Yeah.
Okay, all right. So it says calculate the deceleration of the car for the last 5 seconds of the journey. Now, Abdullah, do you know what does deceleration mean?
The car's slowing down.
Very good. It's basically the opposite of acceleration. Okay. So how do we calculate deceleration? That's simple.
It would be
Very good.
so it would be, would it be 16
Hmm.
over 5?
Yes, but that
Do you have
is
to put it?
gonna.
Do you have
Okay.
to say minus 16 because it's deceleration?
Actually, you are correct. You are. The thing is that when you are saying deceleration, the answer is going to be 3.2 meter per second square, right? But if the question had acceleration, in that case, that would have been minus 3.2 meter square, right? So basically, we
Yeah.
are going to calculate the deceleration by doing 16 divided by 5. 16 minus 0 is basically giving you the change in speed, and the time taken is 5 seconds, right? So that is
Yeah.
giving us 3.2 meter per second square. Always remember, if the question has deceleration, you are certainly not going to use negative sign, okay? Because
Wait,
they
do you
are,
have to do the change? Do you have to do the change in speed or the original speed?
yeah, change in speed, okay? Change in speed.
So if it was the
Basically,
car goes down, if the car went down to, oh yeah, because if the car went down, say 1 meters per second, you do 16 minus 1 divided by 5.
exactly. So that would
Right,
have been
got it.
3 meter per second square. Very good, excellent. Okay. And then it says calculate the average speed of the car between the two sets of traffic light. Okay, so what do you think about this one?
Average speed. So the average speed is, you have the time, which would be 10 seconds.
Okay, now you need to be clear with this. The diagram shows the speed time graph for a car traveling between two sets of traffic lights. So do you think that these are the two sets of traffic lights between 10 and 20?
Is it?
No, because look, his speed was 16 meter per second. If they are saying it is between two sets of traffic lights, the speed must be zero, and then it should get again zero, right?
Oh, so it starts at a traffic light and ends at a traffic
Yeah,
light.
exactly.
Oh, I know how to do this. So the average speed is, you split it up into triangle and
Excellent.
square,
Excellent. Yes.
and then you add them up. So it'd be, you do the area for the triangle first. So it would be 10 times 16 divided by 2,
Very good.
which equals 80.
Very good.
You do 10 times 16,
Hmm.
which equals 160.
Very,
And then you
very
do
good.
5 times 16 divided by 2, which equals 40,
Very good. Excellent. Yes.
which gives you 280 meters per second. Bash. Is that right?
Wait a second. Okay.
Do you have to add them together after? Or do you have to do something else?
Sorry. Okay. Yeah. Excuse me. Okay. So this is the, okay. So you have multiplied them. Sorry. Basically, this 80, 160, and 40 is giving the information about what?
The different,
The distance. Okay. The distance.
yeah,
Very good. Okay. And what is the
because it's the
question?
area under.
Yeah, excellent. And the question is about the speed. So speed is total distance divided by the time, right? So this is the
Yeah.
distance. 160 plus 40 plus 80, that would be 280. And then you need to divide that by the time, okay?
Is it 25?
Yeah, very good. And now tell me the answer. Now tell me the answer.
8 divided by 25. Oh, answer equals 11.2.
Very good, excellent. This would be 11.2 meters per second. Okay, be careful about the units. Excellent, very well done. Okay, that is good. Let's talk about the next one. Okay, so it says the diagram is the speed time graph of an object during a period of 15 seconds. On the diagram given below, sketch the distance time graph of the object for the whole 15 seconds of its motion. Right, okay, so this is the acceleration time graph. All right, so first you need to sketch the distance time graph and then we'll talk about the acceleration time graph, right? I just wanted to talk about
Yep.
all of it. Okay. So I am gonna make it here. Okay. Distance and time. So we have 5, we have 12, and we have 15, right? These
Yep.
are the 3 time intervals that we have. Okay. So how much distance is traveled in the first 5 seconds?
It would be, you have to find the area of everything under.
Yeah.
So it would be 30 times 5 divided by 2, which equals 75. And then you have 20 times 5, which equals 100.
So it is in total.
Oh, no, I'm just doing it now. And then you have 7 times 20, which equals 140. And then you have 20 times 3. 20 times 3, which equals 60.
Okay, but in order to understand this, we need to do it stepwise, right? In the first 5 seconds, how much distance is traveled?
In the first 5 seconds, 175.
Okay, so this is 175. Okay, and what about
In the next 7
this?
seconds, 140.
Okay, so it's 140, and then
And then you split it up into another triangle and square.
hmm,
So you do 20 times 3 to get you 60. And then and then do you do 36 2/3? I think is it 36 2/3, that number?
yeah, okay, that number, yes, that is 36 2/3.
So that means you do 16 2/3 times 3. 16 times 2/3 times 3, which gives you 32, but you divide it by 2 to get 16. So the distance covered in the final 3 seconds would be 76.
All right, okay.
Is
So
that right?
yeah, okay, so
Oh,
basically this is what we have. This is 3 and that is 20. So this is giving you 60, right?
and then the
And then,
next one gives you
yeah,
16.
so this is 36 2/3. Okay, that would be 36.67 minus 20. Yeah, that is approximately 16.
Yes.
So it is going to be the height. Let's write it down this way, and then this multiplied by 3 divided by 2. All right, just check your answer again. It is, let me see. It is 85. Check that
Yeah,
again.
but then don't you find the area? Because you do 16.7.
Multiplied by 3
Yeah, and then you
divided by
divide by
2,
2.
and then plus.
Oh, okay, I see where I want. So 25.05. So
Yeah,
it's 80.05.
it is 80.05. Very good. 85 point something, right? It's
80 upon side 60. 85.05.
yeah. Okay, so this was the distance at 5 seconds. Then the distance traveled. All right. Now we need to understand one thing, that the distance traveled after 40 seconds is not after 7 seconds is not 140. Okay, it is basically the distance traveled between this time. So we need to do 175 plus 140. Let me make a figure graph and you will get the point. Okay, so let's say this is the y-axis, this is the x-axis, this is the distance, this is the time. All right, so this is 175. Then for this, we were getting, what was this exactly, Abdullah?
240. 140 actually, 140.
Yeah, 150. So this is 140. And then this was 85. Okay. So at time equals 0, the distance traveled was 0, right? So this is going
Yeah.
to be the first dot. Then at time equals 5, The distance traveled was, let's say this is 50,
175.
yeah, 100. Then we have 150, then 200, 250, 300, and then we have 350. Okay. So it is going to be 175 somewhere here. And then after 7 seconds, yes, we are covering an extra 140 meters, but that should be 175 plus 140, right? Because we are going to talk about the total distance that we have covered in the first 12 seconds. So that is 315.
Yes.
So it is going to be somewhere here, right? And then if I write down the 15 as well, that would be 315 plus 85. So it is 400. So it would be somewhere up there. Okay. So this is going to be a line of this type. Obviously, I did not make a proper line because I did not make it on scale. And since I did not have, the grid and all that, so I was not able to make the proper line, right? But you just need to connect the points as neatly as you can, right? And that,
Wait, so
hmm,
at 12 seconds, did you have to add up the 0 to 5 distance and 5 to 12 distance?
wait a second. Wait a second. Say it again.
So between 0 and 5,
Hmm.
the distance was 175.
Yeah, it was this point.
And then at 12, it was 140. Or would you have to do 175 add 140?
Yes, yes.
And
Okay.
why would you do that?
Because at
Is it total
time,
distance not
yeah,
covered, not just
exactly.
between seconds?
Exactly. Yes, yes, yes.
Right.
Okay. All right, Abdullah, do you think that this graph would be correct? Do you think that this would be correct? Like if we connect the points directly, yes, that would be correct. But like, what do you think? What is your opinion?
Yeah, I think it looks
Okay.
okay.
So didn't we talk about the link between distance, time, and speed time graphs? When do we get this shape and speed time graph? And when do we get this type of a shape and speed time graph? And when do we get this type of a shape and speed time graph? Right?
The first one,
Hmm.
oh, because he's
Exactly.
decelerating at first.
Yeah. So
Or like what? No, he's decelerating at first, and then it's constant acceleration. It's constant. It's like he's going the same speed, and then he's accelerating.
yeah, but I don't want you to talk about the acceleration. I want you to think about the distance time graph and the speed time graph. Okay. So we have just discussed this. I will share the whiteboard again just so you are able to understand. Okay, I've shared the again. Look at this now. When are we getting this shape in the speed time graph? When the distance time graph curve is of this type. When do we get this type of a line for speed time graph? When the distance time graph is of this type. And when are we getting this? We're getting this where it is increasing, right? When distance time is
Yeah.
increasing, okay? So keep these
Yeah.
in your mind. You can take a picture and then I'll go to the questions again, okay?
And I've got them drawn on.
Okay, okay. So I will go back to the questions PDF. Okay. Now, this, let's say this point is 175. Then it would be 315. And then it would be 415, but I will use a different color for that now. So let's say it is something of that type, right? I just need to connect the lines. Okay. Now for the first 5 seconds, the shape is going to be of this type, right? This is what the shape would be. And then when I have a horizontal line on the speed time graph, it means the distance would be traveled this way, right? We are going to have a straight line for this horizontal line. Are you getting my point?
Oh, so you don't curve it, you have to line it up straight because it's constant.
Yes. And then for the
So
last part, that is
would you
increasing.
do a curve, but like not left to right, right to left? So you go like up rather than like you go like a U rather than an N, if that makes sense.
Very good. Yeah, that makes sense. So it
Yeah,
would be
like that.
something of this type. Very good. Okay. So now obviously this is not neat.
Yeah, that makes sense.
Yeah, I am going to remake it on the speed time graph and that would make more sense. We are not interested in the values now. We have understood the concept about the values. I just want to talk about the shape. Okay. So for the first 5 seconds, it would be something of this type. Then it would be a straight line and then it would be increasing. So this is what we need to understand, right? So this is the basic idea about the
Yep.
distance time graph and the speed time graph, right?
Yep.
Okay. Now I want you to make the acceleration time graph, okay, using the speed time graph. So I am going to give you 1 to 2 minutes to think about it, make the graph, and then you can share the picture, okay? So I will mute. I'll give you 1 minute and then you can send it to me.
Let's tip this down. If it's the same, it goes up, accelerating. So you would do
Yes, Abdullah, are you able to do it?
yes.
Okay, that's really good. I'll zoom out just so when I make the two graphs, we are able to see them.
So it would be between 0 and 5, it would be a straight line underneath 0.
Okay, so it would be something of this type.
Yes.
Okay,
And then between 5 and 12, it's a straight line at 0.
very, very good.
And then it is a straight line between 12 and 15 at anywhere above 0.
That is correct. Very good. But this line is steeper than this line. Do you agree?
Yes. Yes.
Okay. So the negative acceleration or the deceleration would be more than the acceleration, right? So I need to
So,
be careful while making this line. So this line should be here. For example,
okay.
let's say this is -4. I'm just giving an example. Okay, obviously you can calculate that as well. Let's calculate that. Okay, let's do things how they are actually. So what would be the deceleration in the first 5 seconds? Can you calculate that for me?
Acceleration is speed divided by time. So
Change
be
in speed divided by time. Okay, change in speed.
change in speed divided by time.
Yeah.
There's a triangle.
So
Triangle speed
initially
divided by
it's
time.
50 and then the speed is 20. So what is the change? Change
30
is,
divided by 5, 6.
yeah, so it is -6. Okay, it is
Yep.
deceleration. The initial was 50, the final one is 20.
Yep.
So initial minus final divided
Delta
by
speed
5.
over time.
Okay, very good. And what about the acceleration from 12 to 15?
Acceleration is between 16.7 divided by 3 equals 5.57.
Okay, all right. So it is 36.67. That is the initial speed, and then the final one is 20 divided by 3. So it is 5.5. Very good. So this is 5.5. This means that this line should be somewhere here. Okay, let's say this is 6. It should be under 6. So I'll remake this and it would be somewhere here, right? This is what I wanted to tell you. Okay, did you understand this?
Yes.
All right, let's see if I have another example. Okay, yeah. So basically the first part of this example is done. Copy each graph into the squared paper, answer the questions. For each graph, find the length of, okay, now some of the questions, like the first one was a past paper question, and then some are some random examples just to understand the concept, okay? The length
Good.
of time spent stationary. Now, all these are basically for the first one. Let's talk about for the second one, okay? Now, this
Okay.
is the distance time graph. It says part A says the length of the time spent stationary. What do you think?
3 hours.
Very good. Okay. And then the next part,
Pardon?
the next part B.
Speed when moving the first time. So it'd be 25 meters per second.
All right. So it says the speed when moving for the first time. All right. So that is
25 kilometers an
very
hour.
good. Yes, that very good. So 0, this is 50 divided by 2. That will be 25. Okay. The speed when moving for the second time.
40 kilometers an hour. -40.
Yes, this is. Now, obviously, the speed cannot be negative. Okay. This is 25. Okay. Now, if you think about the distance time graph, what do you get for this one? It would be,
40.
yeah. Okay. I got your point. Okay. So basically, if we make the distance time graph, yes, you were correct. Very well done. This is going to be a line of this type. Then it would be on 0, and then it would be on the
Yes.
negative y-axis. Very good. Okay, I misunderstood. Yes, that is correct. The speed would be negative. Okay. And then the fourth part is the total distance traveled. So can you calculate total distance traveled? So it is going to be all this distance.
50. Do you have to find the, do you just, is it just adding it up, or do you do 50, is it 90?
Okay. The total distance traveled is basically, I'll do it.
Or do you have to
So
find the area?
no, no, no. This is the distance time graph, right? You do not calculate the area for distance time graph, okay?
Yes.
Because you can find the distance directly. Now, for the first 2 seconds, the distance traveled was 50, okay? And then the distance traveled was 0. And then what happened next?
He travels 40.
From 5 to 6, the distance traveled initially was 50 and then it started decreasing. But then the distance was 40. So think about it this way, that you go out with your family to an ice cream parlor, you reach there at this time, the distance is constant because from 2 to 5, like for 3 hours, you're staying there, you eat ice cream, you do whatever you want to, and then you go back. Okay.
Yeah.
So this means that you are going back. Okay.
Yeah.
So this is the distance for the journey back. So this is 10,
40.
20, 30, 40. Very good. So initially we traveled 50 and then for going back we traveled 40. So that would be 50 plus 40, that is 90
90.
kilometers. Yes.
Yeah, I said that.
Okay, I'm sorry. Right, that is good. And then the average speed for the whole journey. So that is now very simple.
Average speed would just be distance divided by time.
Hmm.
And you have the whole 90, and you have the time, which is 6. So it's 15.
Yeah, so you have done 90 divided by 6, and that is
Yeah.
going to give you 50 kilometers per hour. 15 kilometers per hour. Very good. Right. So anything that you did not understand?
No.
Any questions?
Oh, no, I get it.
All right, that's perfect. And stop.